Hey y'all, in this video I'm going to get into Mach3 and we're going to set it up to be able to run my rotary axis. Before we do that, however, I need to clear something up. I've had a few people PM me, I've had a few people comment on the video, and I've had a few people just comment on posts that I've done in some of the Facebook groups, telling me how I could have used the motor that came with this rotary axis with my Xylotex Drive Box. Now I want to clear that up right now. And I guess I didn't make it clear enough in the first video. The system I'm using is the old style Xylotex Drive Box with a single parallel port on the front. I'm not using one of Jeff's newer Drive Box kits. The old one did not have the separate controllers for each axis. It was all together on one board. So for the folks who said I could get in and adjust the voltage and the amperage on the controllers, no, I can't. Not on the old style Drive Box. Now this Drive Box, I got this Drive Box in 2015, so it's definitely one of the old style. Now those of you who read the website article know that when I discovered that the pulley from the motor that came with this unit wouldn't fit this motor, I contacted Jeff and I asked him specifically about that. Is there a way that I could use the motor that came with this axis with the Drive Box? And he's the one that told me, no, you can't use that. You'll need to switch over to this motor. And he knew I had this spare motor. I reminded him of it in the email. So it's not like he saw the opportunity for a sale here. He knew I had this motor. He's the one who told me that there was no way to get into this Drive Box, adjust voltage or amperage to make it work with the other motor. Now, I've been working with Jeff off and on since 2015, and I think I know him well enough to know that he's not the kind of person who would just flat out lie to me for a $40 stepper motor sale. And I tend to believe the people who design and build the equipment that I'm using over somebody with a theoretical possible way that I could make something work. So you electronics wizards who know what you're doing with this stuff may be able to come up with a way to make that motor work with the Drive Box. And that's great. I'm just not that guy. I want a plug-and-play solution, which is why I went with the Drive Box to begin with. And according to the man who designed it and built it, there was no way of adjusting anything to make that motor work with this Drive Box. And I already had this motor, so why not use it? So, I hope that clears that up. I do appreciate your input, and please keep coming up with it. But there's a reason why I changed the motor, and that reason was because the person who designed and built the Drive Box said I needed to. And that's good enough for me. So, now that I've spent 3 minutes yakking about that, let's get into Mach3 and get this puppy set up so that I can actually take this for a spin. Literally.
The first thing we need to do to set up the rotary axis is create a separate Mach3 profile for it. So we'll open up the Mach3 loader, then we're going to click Create Profile. Now from here we can go in a couple of different directions. We can clone the profile that we already use, or we can choose one of the factory profiles and clone that. Either way, we're going to have to get in and change a bunch of settings and enter settings, so it doesn't really matter which way we go. Personally, I'm going to clone the Mach3 mill profile. That's straight from the factory. I don't want to use Mach3 turn because that's designed for a CNC lathe. Now, rotary axis is not a CNC lathe. There are some major differences. The rotary axis is just an accessory to the CNC router. So I'll clone the Mach3 mill profile. I'll select the profile by clicking it, then come up here and give this new profile a name. And I'm going to call it Rotary axis. Then I'll click the OK button. Now you see the rotary axis profile has been added down here. So we want to start this profile by clicking it, then click OK. Okay, when the profile opens, we see we're in an emergency e-stop, and we go ahead and clear that. I should mention here, if you can't clear that hard reset, what we'll need to do is to go up here into Config menu, go into Ports and Pins, then come over here to the Input Signals tab. And here we'll scroll down to e-stop, and here in the active low column next to e-stop, you'll see a green check mark. Uncheck that so that you have a red X. You have red X's across the board here. It won't let you disable it, but it will let you uncheck the active low here. Then click OK, and you should be able to reset. Okay? So, from here, what we'll need to do is to go up into the Config menu, and I'll be coming up here a lot. And this first item here in the Config menu is Select Native Units. Now we'll get a warning here that this is not to be used to change between metric and imperial G-code. This is for setting the units that we're going to use in motor tuning. And here we'll select, if you're going to use imperial, select inches. If you're going to use metric, select millimeters, obviously. Once that's done, we'll click OK. Now, I'm going to be doing this a lot. We've made a couple of changes, so we'll go up to the Config menu, come down, and hit Save Settings. It's important that you do that every once in a while. And it's real important that you do that if you make any configuration changes. It's important that you hit that Save Settings before you close Mach3. Going to the Config menu and clicking on Save Settings writes all of the changes you have made to the hard drive. If you don't hit Save Settings, the changes that you've made will apply to this session of Mach3 only. And when you close Mach3, then reopen it, all those changes will be gone. They'll be lost. So it's important, after you make any configuration settings, to come down up to the Config menu and click Save Settings. So you'll see me doing this a lot. So now that we have our native units set, we can go over and check and start our motor outputs. So we'll go to Config, Ports and Pins. We'll ensure that our kernel speed is set correctly. For my case, I'm using 25,000 Hertz. Then we'll make sure that we have the proper port enabled. Then we'll go over here to Motor Outputs. Now, this has already been configured for something, I don't know what. We're going to be enabling the X-axis, the Z-axis, and the A-axis. We will not be using the Y-axis. So I'll uncheck the Y-axis. I'll make sure my step and direction pin numbers are correct. These don't appear to be correct, so let me change these now. My step pin is number 2. My direction pin will be number 3. These don't matter, so I will go get rid of these because we are not going to be using the Y-axis. And on the Z-axis, I should have number 6 and number 7, and the A-axis, My step pin number will be 8, and my direction pin number will be 9. We want red X's in both of these columns here, and we want to make sure that our ports, step port and direction port, are both set to the port number that we're using here. So I've got port 1. I'm using port 1 here. So now we'll hit apply and click OK. We get another reset because we changed our configuration. We'll go up here, click config, and then save settings to write it to the hard drive. Next, we'll need to go back up here to config and then come down here to slave axis. Select that, and we need to make sure that we have none marked in all of these 3 boxes. We are not running any slave axes or axes, for those of you who can speak. We're not running any slaved axes in this profile at all. Now, it says here restart Mach3 after resetting these selections. We'll be restarting it no matter what. So it's not real urgent that we do that right now. We just simply click OK. Clear our reset. Config. Save settings. Now we'll move on. Now we're going to go up here to the config menu again and click on General Configuration. Here in General Configuration, we want to come down here to the Angular Properties and make sure there's a check mark here in A-axis is Angular, B-axis is Angular, and C-axis is Angular. It already is. Now, we'll also need to come over here under General Configuration and make sure that there is no check mark here with home slave with master axis. We have no slaved axis on the A. There's no slaved axis on this profile at all. So we make sure that there's nothing there. Then we can come over here and click OK. Then go back up to config and save the settings. Now we're going to get into motor setup. So we'll go up here to the config menu, go into motor tuning. We look over here under axis selection. We can see that only the X and the Z are lit up. That's wrong. So I need to go back and see what's going on here. Ports and pins, motor outputs. I didn't enable my A-axis. There's your problem. Now we'll hit apply and OK. Hey, it happens. Save settings. There. Now if we go into motor tuning, we see the X, the Z, and the A-axis are all 3 lit up. Y-axis is not lit up because we did not enable it back in the motor outputs. So now we can go ahead and set up our motors. If we look up here, we are in the X-axis motor movement profile. If we come over here and click one of these buttons, we're working in the Z-axis. Over here, we're working in the A-axis. So we'll want to go ahead and start with the X-axis. Now we already know in Mach3 with the Xylotex Drive Box and the Xylotex stepper motors that the steps per, in this case steps per inch, is 6,400, and that is set already here. The velocity, I'm going to back down to 100, and I'll explain a little bit later why. And I'm going to set this at my acceleration at 4 inches per second. And if we look up here at this profile, what we're seeing is it will take approximately 0.7, 0.8, approximately 0.8 seconds for it to get from a dead stop to 100 inches per minute. And while that's not a super speedy acceleration rate, it's quick enough for me. So we'll go ahead and accept these settings: 6400, 100 inches per minute, an acceleration of 4 inches per second. And I'll come over here and click Save Axis Settings. And you'll have to save the settings for each axis when you do this individually. Next we'll come over here and we'll hit the Z axis and we'll do the same thing. I'm going to go with 6400 steps per. I'm going to bring this back down to 100 inches per minute, and this is the max rapid rates, by the way. This is not the feed rate. And I'm going to go with acceleration of 4 inches per second. Then we'll hit Save Axis Settings. Now the fun one, the A axis. Okay, when they said that there would be no math, they lied. We're going to need to do some basic math here, so go ahead and grab your calculator and get it ready. Okay? The first thing we need to do is forget almost everything we know about the X and the Z axis and everything else in the other Mach 3 profiles we use. This axis is completely different. All of the other axes are linear. This axis is angular. There's a tremendous difference. Okay? The linear axes are based on steps per inch. This axis, because it's angular, is based on steps per degree. So we'll need to get some basic info and do a little bit of math before we can enter our steps per here. Okay? First, we need to find out how many steps our stepper motor takes to turn one complete revolution. Now, in the case of the Xylotex motor, that number is 3,200 steps. Now, I hear a couple of you out there screaming, no, that should be 6,400 steps. Well, let me address that right now. On the linear axis, meaning your X and your Z, the motor turns 6,400 steps to move that axis 1 inch. Well, on the rotary axis, we're not moving the axis. We're rotating it on its center. If you enter the command into Mach 3 to move one of your linear axes 1 inch, count the number of revolutions that motor makes to move 1 inch. You'll find that the motor actually turns 2 complete revolutions. So that's 6,400 steps to move 2 complete revolutions, which moves that axis 1 inch. We only want the number of steps it takes to turn the motor 1 complete revolution, which would be half of 6,400, which is 3,200. You follow me? So we have the number of steps it takes to turn the motor 1 complete revolution. Now we need to know the drive ratio on the rotary axis. Now, in the case of this sun-wind rotary axis that I bought, that ratio is 6:1, and that ratio should come with the documentation on whatever rotary axis you bought. That means it takes 6 revolutions of the stepper motor to turn the chuck 1 complete revolution. So to find out how many steps per degree to enter here in the steps per box, the math is going to be something like this. Get out the calculator, and we know it'll take 3,200 steps for 1 revolution. Then we'll multiply that by the drive ratio, which is 6:1. So we'll take 3,200 times 6. Hit enter, and we see it takes 19,200 steps to rotate that chuck 1 complete revolution. Now that one revolution is 360 degrees, so we will need to divide the number of steps by 360. So we'll take that 19,200 divided by 360, and we end up with 53.33333 recurring. That's the number of steps the motor takes to turn that chuck 1 degree. So that's what I'm going to enter down here in my steps per. 53.33333. I'm going to stop at 5 decimals. I don't know how many Mach 3 will let me enter, but I figure 5 to the right of the decimal should be good. For the velocity, I'm now going to scare the bejesus out of some of you folks by entering 2,500. Now, again, let's forget everything we know about the other axes. In the other axes, 2,500 would be 2,500 inches per minute. In this case, it's 2,500 degrees per minute. So for instance, if I set that velocity at 360, that means it would take 1 minute for the axis to make one complete revolution. That's way, way too slow. At 2,500 degrees per minute, it should take less than 10 seconds for the axis to make one complete revolution, probably somewhere in the neighborhood of 8 seconds. That's not very fast at all, but it's fast enough that a simple rounding toolpath won't take an hour to do. Well, hopefully anyway. Now the acceleration, I'm going to scare you again and put in at 485. Again, that's degrees per second. That's not how fast the axis is going to turn. That's how fast it's going to accelerate to the speed of 2,500 degrees per second. So remember, this is all in degrees per minute, in this case degrees per second, not inches per minute. Now we'll come over here and save the axis settings. Well, okay, it did change after I didn't hit enter down here. So we're going to take about 0.7, 0.8 seconds to get up to, well, no, 0.08. That is actually pretty quick. That's okay. I can always come back and adjust it. So we'll save those settings, which I already did. Hit OK. Come up to Config, Save Settings, and we're good. Okay, those are all the settings that we need to go ahead and do a test. But before we do a test, we need to restart Mach 3. So we'll go up here to File, Exit, Yes, end the session, let it close. Then we'll come back down, start the Mach 3 loader, start the rotary axis, hit OK. Okay, and with the rotary axis profile now reloaded, we can go ahead. We're ready to do a rotary axis test. Now, something that I'm going to have to watch for on the machine is the direction of the motor rotation. If I lean over the table and look at the face of the chuck, positive rotation should be counterclockwise. So if I stand in front of the machine, the top of the chuck should appear to be turning toward me. If it's not, I'll need to reverse the direction of that stepper motor by going up here to the Config menu and going to Homing Limits and putting a check mark here under the reversed column right next to the A axis. The only reason that I'm mentioning this now is because it's easier for me to show you on this screen capture than it would be on the CNC when we do the test. Speaking of which, let's go test it.
Okay, let me describe my setup out here. I don't know if you can hear this or not, but right now the controller box is turned off. It's crucial that the Xylotex Drive Box be shut off before you do what I'm about to do right now. That's critical. Do not, I say again, do not unplug the axis from the drive box or plug the axis into the drive box with that drive box turned on. If you do, you will fry the motor, the drive box, or both. It will happen. Don't do it. Now I have my Y-axis stepper motor is over here on this side. My other slave axis, which in the normal configuration would be the A-axis stepper motor, is over here. I have an extension cable that I got from Xylotex, and I'll put a link in the description box below, plugged into that motor, and that cable runs underneath the table and exits right here. I'll come in for a close-up in just a second, but you can see I have the blue cable coming out of the drive box, which is the A-axis cable, plugged into that blue extension cable that runs back to that motor, which is the slave for my Y-axis. Now I'm going to keep the Y-axis positioned way back here for this test, just so we can see it without the router and the dust collector shoe and everything in the way. So let me go ahead and bring you in close so you can see what I'm talking about. Okay, pardon the mess, but here's where I've got going right here. Here's the extension cable that comes out of the motor back on the rear end of the table, and this is the cable here that comes out of the drive box. And I've got my axis motor, my stepper motor, back on the left rear corner of the table, plugged into it right now. Now, again, this is critical that the drive box be shut off before you do this. I don't mean before you kick the camera. With the drive box shut off, I can now unplug the A-axis motor and plug in the rotary axis motor. And I'm going to come up with a little bit better system than this. I'm thinking about mounting a control panel or a small box off to one side with these two plugs in it so I can just unplug one and plug it into the other. But I don't anticipate making this change very often. But with this plugged in now, I no longer have my Y-axis cannot move. So what this means is I'm going to have to position my Y-axis over the center of the rotary axis, power everything down, unplug the slaved motor, then plug in the rotary axis, then before I can load the correct Mach3 profile and fire up. And when I get ready to cut my first piece, I'll go back over that and show you what I'm talking about. So with all this hooked up the way it is right now, I'm ready to go ahead, turn on Mach3, turn on the drive box, and do my tests and make sure that my rotary axis turns the correct way and that I got all of my settings in Mach3 correct. Okay, let me apologize beforehand. Here in my itty-bitty shed, there really isn't a great place to stand where I won't be in the way. I've tried to position to where you can see my screen as well as the axis when I do the test. So now what I'm going to go ahead and do is I'm going to go ahead and fire up the profile, the rotary axis profile. Let that load. And there we are. Now I have the rotary axis plugged in to the correct cable. I'm all set and ready to go. Now I can turn on my drive box. We're all set there. You'll notice that I left the reset going. I want this under Mach 3's control before I clear that reset. So there we go. Now I'm ready to do my motion tests to make sure that I've got all my settings correct in this profile. So to do that, I'm going to come over here and hit the tab button on the keyboard, and that opens up the MPG mode display on the side of Mach 3 here. Now using the mouse, I'm going to hit my jog buttons for the 4th plus and the 4th minus. Now when I click on the 4th plus, what should happen is the chuck should rotate this direction towards the front of the table. Let's see if it does that. It does. Now if I hit 4th minus, it should rotate the other direction. And it does. That means I do not have to go in and reverse the motors. I don't have to be concerned about that. What I will need to do is go in and program some hotkeys so I can turn the axis using my cursor up and down buttons. But I'll get into that in just a minute. So right now, what we can do is we can take a look and pay a little bit more attention to the speeds at which this axis is turning. Now, if you remember, I have this set to run 2,500 degrees per minute. Let's see how long it takes. I've got my chuck marked here. Let's see how long that takes to do a 360 degree turn. And I'll do that by clicking 0 on my axis. So we've hit 0. Then I'm going to go into the MDI screen and tell it to turn this axis 360 degrees in the plus direction. And then we'll just count and see about how long that takes. So I'll hit the tab button to get rid of the MPG mode. I'll go over here to my MDI screen and I'll type in G00 space A360. Now when I hit enter, whoops, I got to put my cursor in the right place first. The wonders of trying to do it on video. So that's G00 space A360. Now when I hit enter, it should start turning. 4, 1005, 1006, 1007, 1008. That took 8 seconds for that axis to turn 360 degrees. I can live with that. That might be a little slow. I'm not really sure. But it didn't take off. It didn't tax the system at all. It's moving in the correct direction. It works. So now let's go counterclockwise. What I'll do is I'll enter a G00, a negative 360, and turn it back the other way. So G00, a negative 360, enter. And, what I should have done was enter G00, a 0. Because what it just did is it went from positive 360 degrees to negative 360 degrees. So that was 2 full revolutions back. Like I say, it's going to take a little while to learn how to use this. But it works. It moves. There are no sparks, no flames. I'm a happy guy. Now let's go inside and program some hotkeys.
Okay, with our tests done, we're happy, got it moving, everything is great. Now we're going to get back into Mach 3 and we're going to go ahead and load some hotkeys for use with the rotary axis. Now, I've already done this, but I'll do it again. So we'll go up here to the Config menu. We'll come down here to System Hotkeys. And in this screen here, we need to remember that the Y-axis is not being used. It's not enabled. So we don't have to worry about any numbers that's already programmed into the Y-axis. They are irrelevant. So with that in mind, what will come down here to the A/U++, and we'll go ahead and just click that button. Now Mach3 is prompting us to press the key that we want to use for a positive A-axis rotation. Now positive rotation on the rotary axis is the top of the chuck moving towards us. So just to keep that straight in my mind, I'm going to use the cursor down key. So I'm pressing the cursor down key on my keyboard now. That goes away, and the number 40 is entered here in this blank. Same thing with the A-axis/U --. I'll go ahead and click that button, and conversely, I'm going to use the cursor up button, which will make the top of the chuck rotate away from me standing in front of the machine. So I'll go ahead and push the cursor up button now, and that window disappears. The number 38 is entered. So now I can use the cursor down to rotate one direction, the cursor up to rotate the other direction. Again, because the Y-axis is not being used, it's not enabled, any number up here doesn't matter. Mach3 knows that it's disabled. So we can go ahead and click OK. Come back up to Config and Save Settings. Now, what we're going to do is we're going to prepare Mach3 to actually run some G-code on the rotary axis. And the first thing we'll do is we'll go up here into the Config menu and click on Toolpath. Now, what we're going to focus on is this area over here in the rotations box. The first thing we're going to do is put a check mark in A rotations enabled and use radius for feed rate. That's going to make Mach3 use the radius of the piece of material we chuck into the chuck to calculate the feed rate down here. Now we're going to need to know the axis of rotation. We have a working Z-axis, we have a working X-axis. The way I have my rotary axis mounted to my CNC table across the width of the table, parallel to the X, it is mounted, the axis of rotation will be on the Y. So we'll put a check mark here. Okay? Then we'll go ahead and click OK. Then once again, Config and Save Settings. Now what that does is helps the toolpath window over here display it correctly and again calculate the feed rate. Speaking of this toolpath window displaying the toolpath correctly, your G-code that you load over into this window here, we go on to the next setting. This setting will have to be done every time you put a new piece of material into your chuck, unless you're absolutely certain it's the same size. We'll go up here into the Settings tab right above the Axis DRO button, and we're going to come over here to the top right corner where we have Rotation Radius. This DRO here for the A-axis is the one we're going to concern themselves with. And what it needs to know is the radius of the piece of material we're physically putting into the chuck. So if I have a piece of material that's 1.5 inches square, the radius of that material is half of that 1.5 inches. So in that case it would be 3/4 of an inch. So what I would do is I would click the DRO here and then enter 0.75. Then hit the enter key to set it. That tells Mach3 that my piece has a radius of 3/4 of an inch. So it knows to use that radius to calculate the feed rate and make sure that the toolpath displays correctly. Back here in the Program Run tab, it will now display correctly here. Now if you look over here next to the 4th axis DRO, the radius correct LED is lit up. That tells me that I did enter a value over here in this DRO. If I didn't have a value entered over here, this LED would not be lit up. I'm now ready to go ahead and chuck a piece of material that's 1.5 inches square in the DRO, in the chuck, load my G-code, and start cutting. And again, this will have to be done every time I put a piece of material into that chuck. So that's it for Mach 3. We're now ready to go ahead, load some G-code, and turn apart on the rotary axis.
But that's going to be another video. This is not the permanent location that I'm going to be running this rotary axis. In fact, I'm going to be mounting it down here inside this cutout, which is why I made the cutout in the first place. It's mounted up here just for testing purposes only. So, I want to thank everybody for watching this, taking the time to check this out. If you got anything at all out of this video, please do me a favor and hit that thumbs up down there. If you'd like to keep up with my CNC adventures, in the next video, I'll have it mounted and I'll be actually cutting apart. Knock on wood, or MDF anyway. If you'd like to follow my CNC adventure, hit that subscribe button down there. And then click that little bell right next to the subscribe button. Then you'll get a notification the next time I post a video. Now, once again, I'd like to thank you very, very much for watching. I put a link in the description box below to the website article that's going to accompany this video. And there's going to be more information, more details, not to mention a screenshot of all of the Mach 3 screens that we went through in every step of setting this up, so that you can take a look at them at your leisure, maybe even download the pictures, and be able to refer to set up your rotary axis to work with your old style Xylotex Drive Box. So, again, I'd like to thank you very much for watching, and y'all take care.